So, hey guys, uh, this is here. Uh, Today I'm discussing the next part of SN1 and SN2 reaction, how SN and SN2 reaction perform, and which pathway a reaction, a organic molecule uh, takes part or perform reaction. Okay, so previously I discussed a, bromoethane, methyl bromide in aqueous base. It gives alcohol. Okay, so means alkyl halide which perform reaction to give alcohol. Okay, so obviously that is called the hydrolysis of alkyl halide. Okay, so 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 rate actually K2 alkyl halide OH minus, that is bimolecular cular. Okay, bimolecular. Okay, that means you know a reaction that is bimolecular, that is SN2. Okay, nucleophilic substitution bimolecular. Since here the alkyl halide and OH minus both are very important, and both the concentration, this is the concentration term that we define into the third bracket. Okay, so both the alkyl halide concentration and OH minus concentration depends a rate of a reaction that is called SN2 reaction. Okay, so here OH minus is via dashed position and ways. Dashed mean this dash means if paper जो है ना, if dash means the below the paper. Okay, below the paper. Okay, below the paper, and the wedge means above the paper, above the paper. Okay, that is the central carbon attached three hydrogen and one bromine atom. Okay, this is called alkyl halide. Halide means a bromine attached to the carbon. Okay, so here the carbon is sp3 hybridized. Okay, sp3. Okay, here the carbon actually sp3 hybridized. Okay, so when a nucleophile, that is a OH minus, attack to the electron deficient center, that is a carbon. Okay, electron deficiency means when a more electronegative atom attached to a carbon atom, then obviously that due to the electronegativity of more electronegative atom, it's pull up the bonding pair of electron towards itself. Means bromine is more electronegative rather than carbon. So bromine pulls their bonding pair electron towards itself. Okay, so due to their pulling effect, due to the pulling effect of bromine, due to the bonding pair of electron pulls towards bromine atom, hence bromine got del minus positive, del minus negative charge, and the carbon has electron deficiency. Okay, you understand? Okay. Uh, 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 mm, uh, okay. So, so see, electronegativity difference between this bond is greater than CH bond. You know, CBr. Okay, carbon has electronegativity 2.5. Okay, and bromine has electronegativity 2.8. Okay, and carbon and hydrogen, this bond, the carbon has electronegativity 2.5 and hydrogen electronegativity 2.1. So the electronegativity difference between this bond actually are 2.8 minus 2.5, that is 0.3. Okay, obviously this is 2 point, you know, you know uh bromine atom, the electronegativity actually 2.8, that is it is too high than carbon. Okay, that's why its bonding electron its bonding electron pulls up towards bromine atom. Okay, so bromine got del minus charge and carbon got del positive charge. Okay, so here obviously here electron deficiency occurs. Okay, so carbon has electron deficient center. Okay, so when O is minus, that acts as a nucleophile. Okay, okay, that goes to the electron deficiency center, that is carbon. Okay, so here formation of a state that is called a transition state. It is that state you can't see this. Okay, it is a very short time, and experimentally it is not verified. It is an imaginary state that is called a transition state. Okay, um, okay, that is called transition state. When O is minus, that is nucleophile, nucleophile, nucleophile. Okay, that is a electron rich, electron rich. Okay, attack to the electron deficiency carbon center, and then obviously due to the electronegativity of bromine atom, and as well as bromine is a good leaving group. When O is pushes their electron towards carbon, obviously bromine removes out. Okay, then a state that is called transition state. Obviously O is negative charge. Obviously when it gives electron to the carbon deficiency carbon center, obviously this negative charge will convert del minus, okay, and carbon there is a attached form, and just we can see when just O is minus attack C, then Br minus removes out, okay, as it is. uh, there is no change. This three hydrogen that is below the plane, that is below the paper, okay, this is my paper, okay, and it is a plane, okay, this is my paper and it consider a plane, okay, that is 2D. When it's up, then this dash means the hydrogen atom is below of this plane, okay, this plane, the hydrogen atom actually below the plane, okay, and this hydrogen that is waste form, actually this is the above of the plane, that is plane, above of the plane, this is the plane that is above of the plane, okay, you got it. So this actually a state that we imagine that is called a transition state, okay, transition state, and this the symbol actually is called a double dagger, okay, this is the symbol of transition state, transition state, okay. So it is not experimentally verified, it is short term, that is uh, um, that is 10 to the power minus 14 seconds, means this transition state is is stable, or it can stay at this form only 10 to the power minus 14 second. So now you see, you imagine this is very 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 short term, means it is very unstable state, okay. So from this transition state we obtain product, that is Br minus removes out and O is minus added to the carbon atom, okay, and the product should be this, okay, and Br minus. So all you are got it. It is simple and very interesting. So see, uh, actually a rate, a reaction, that is a reaction, simple reaction, and when we use a kinetics that already I discussed in previous lecture, okay, so so that is a reaction, and the reaction you see depends uh, the substrate, that is a alkyl halide as well as a nucleophile, okay. So the alkyl halide, that is a substrate, and a nucleophile both depends on this both the concentration depends in SN2 reaction. Okay, SN2 reaction, it is very important that the concentration of substance is very important, as well as nucleophile. Okay, so when a substrate is attached to a electronegative atom, then obviously here the CBr bond is polar. Okay, so due to this polar effect, here the electrodeficiency occurs the central carbon atom. So when OH minus attack electron deficiency center, that is the sigma star. Okay, sigma star. Why this is called sigma star? CBr actually a bond. Carbon has 4 electron. Okay, uh, in the valence shell. Okay, and bromine has 7 electron. Okay, due to fulfill their octet, obviously bromine need 1 electron, and that is bonded to the carbon. Okay, so bromine actually bonded to the carbon atom by sharing 1 electron. Okay, both the carbon atom as well as bromine atom share their valence electron, that is 1 electron share with bromine, and bromine also share with carbon. Okay, so the sharing electron actually 2, but bromine has a valence electron that is 7. So bromine and carbon formation occur because octet bromine fulfill their octet. Okay, okay, and carbon obviously fulfill their octet because you know carbon form a bond with a bromine atom with the valence electron by sharing. Okay, obviously here a hydrogen atom, that is the valence shell electron is 1. Obviously this share with carbon. Obviously here is a 2 electron. Okay, obviously here also one hydrogen atom that share by carbon, that is 2 electron. Obviously here also a hydrogen that share by. So see, carbon has 8 electron that fulfill their octet: 2, 4, 6, 8. So carbon fulfill their octet, as well as bromine also fulfill their octet. But bromine is more electronegative rather than hydrogen. Okay, so bromine pulls their bonding electron towards itself due to the high electronegativity than hydrogen. Okay, so this CBr bond actually polar in nature. Okay, polar in nature. Okay, okay, so obviously this bond is too much unstable. Why? Because this bond is polar, and and the uh, and the electron density is towards bromine atom. Electron density towards electron density towards bromine atom. You got it? Obviously, when impulsive force, that is suppose a nucleophile, since it is a sigma bond, by sharing this carbon atom, obviously here is a anti-bonding orbital that is empty. Okay, that is called sigma star. OH gives this anti-bonding gives their electron to the anti-bonding to form a OH bond. Okay, okay. Then obviously this bond break up. Okay, that is Br minus. Why, here is a molecular, or we see molecular orbital theory. When a bond formation occurs, that is bonding orbital and a anti-bonding orbital. ठीक? Anti-bonding orbital. Bonding orbital. Okay. You know, you know, uh, CBr, that is a bonding orbital. Okay. That carbon has one electron and bromine has one electron, two electron. So obviously, if there is a bond formation occurs, that means the bonding orbital has two electron. Okay, so when one electron goes to the anti-bonding orbital, obviously bond order decreases. That means bond dissociation occurs. Okay, very simple and very interesting. See, bonding means when carbon has a share with a bromine atom, one electron, as well as bromine also share a electron to formation a bond. Okay, that is called bonding orbital. Okay, that is okay. You see, MOT. This is MOT theory. That is called molecular orbital theory. Okay. Um, um, okay, it is very interesting. Okay, bonding orbital. So bond order actually half into bonding means B and anti-bonding means A. B minus A. Okay, you know when bonding that is here the bonding orbital two electron. Okay, so 1 by 2 2 anti-bonding 0. It is vacant. Okay, so 1 by 2 minus 0, that is 2 by 2 equals to 1. Bond order equals to 1. That is more bond order equals to 1. You understand? All you understand, guys? Bond order 1 means here is a bond formation occurs. Okay. If if O is minus gives their two electron to the vacant anti-bonding orbital, that is anti-bonding, we denoted it's sigma star. Okay, it is sigma and it is sigma when bonding orbital and sigma star anti-bonding orbital. Bonding orbital CBr, that is two electron. Okay, if O is minus give their two electron to the anti-bonding orbital on anti-bonding orbital, then obviously this bond order breaks because bond order means 1 by 2 bonding minus anti-bonding, 1 by 2 bonding two electron. Okay, uh, now you see when O is there two electron gives to the anti-bonding of carbon atom, then obviously here 2 minus 2 means 0, bond order means 0, means this bond should break. Okay, and this formation occurs. Okay, bond order 0 means there is no bond. Bond order, okay, see, bond order 0 means there is no bond. between the two respective atom. Okay. So see, bond order means there is no bond between the two respective atom. It is very very important, very important, important. Okay, because it is very important from your exam point of view. That is a competitive exam. So or as well as board exam. Um, because you see, bond orders actually defines a bond formation occurs. Okay, so 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 obviously here you see it is a two molecule, that is a one substrate and OH minus. Okay, here it is two molecule, that is OH minus and a substrate. Okay, so so and when there is a transition state formation occurs, obviously here a five molecule, that is impossible. you know you know this transition, why this transition state actually are not not C, and it's stable on 10 to the minus 40 seconds. That is experimentally not verified, and it is a state that we can imagine. It is the beauty of chemistry, it is the beauty of chemistry here. Here, transition state actually it is a thinking, and it is an imagination of by the scientists, that when two molecule react with each other, then obviously a state that is we can imagine, that is a transition state. It is not experimentally verified. That is, it is not found. Okay. Okay. Uh, and later I discuss transition state and intermediate state. Actually, both the different state. Actually, intermediate state can be experimentally verified, and it is widely discussed, and it is widely analyzed by scientists, or it's have many stability factor, and experimentally it is verified. So intermediate state can be experimentally verified, and it is found. Okay, but transition state actually a imaginary state, that is not found, but that is not found. Okay, and its time actually its state actually 10 to the minus 14 second. So now you imagine that it is very 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 unstable. This is called a transition state. Okay. Carbon actually four valence electron. Carbon has four valence electron. Okay, that is one S2, two S2, two P, two P2. Okay, so obviously this is the valence shell. Here the valence shell has four electron. Okay, means two, four. Okay, that is carbon has valence shell four electron. Okay, so obviously it can bond it with four different atom, that is by sigma bond. Okay, by sharing this four electron, like see that valence electron, hydrogen has valence electron 1, hydrogen valence electron 1, hydrogen valence electron 1. So obviously here hydrogen fulfill their doublet, that is two, that is acquire a helium, that is a inert gas, so it is a stable. Okay. Here hydrogen fulfill their doublet. Here also hydrogen fulfill their doublet, that is inert gas, helium structure aqua. So obviously carbon also fulfill their octet. Four electrons is here, that is share its own electron. Also it accepts four electron from four different hydrogens. So obviously 4 plus 4 fulfill their octet. Okay, okay, and that's why I want to say carbon obviously bonded with four different atom. Okay, so that's my point. Here here carbon bonded with five different atom, and it is impossible. It is impossible, because carbon hardly bonded with four different atom. Okay, by covalent bond. Okay, so so obviously here this is the transition state. It is not possible. You see, so that's why I discussed that bond order is very important. Why this five bond formation of carbon is not verified and not. It is the answer because when carbon bromine bond formation occurs, this is called sigma bond. Obviously, here is the antibonding, that is bonding, that is antibonding. When antibonding, when OH minus give their electron to the antibonding, that is bond order 0. Okay, so bond order 0 means there is no bond between the two respective atoms. That is this bond breaks and Br minus removes out, so the product is alcohol. Okay, alcohol is the product. Okay, uh, see, alcohol is the product, and next day I will discuss the how actually SN1 and SN2 reaction depends on the substrate, and mm, in SN2 reaction, actually there is a stereochemistry also important, that is when a substrate react with a nucleophile in SN2 reaction and formation of a product. The product is a product. Actually stereochemically it gives inversion product, and this inversion, how to this inversion occur, we discussed next day. Okay, so in SN2 reaction the product actually we got, that is inversion product. Okay, in SN2 reaction the product actually an inversion product, that is this is the substrate, that react with a nucleophile and we got a product, that is alcohol. This is actually a inversion product. Okay, inversion product. And why this is the inversion product, next day I discussed. Okay, so thank you all of you, and follow my channel, and if you have any problem then you can comments me below the comment section. So thank you.